Hi to all. Today I am going to explain some more concept based on the interference. That is, you see this figure, this is a source S, and from the source S in front of that we are placing one cardboard with two pinholes. And now through these two holes the light passes, and that light rays which are emitting from S1 and S2 are superposed at every point on the screen. In the figure, you see that from S1 the light is coming and emitting at point P on the screen, and from S2 the light is coming and it is emitting at point P. And at point P, the two light waves are interfere with each other. That due to that, based on the path difference or the phase difference, based on the type of interference, constructive or destructive, either at point P, either bright or dark band will be forms. Now, previously we derived the formula for the resultant intensity when two light waves have the same intensity and same amplitude are superposed with each other, that we derived. But here, if they have the different amplitudes, two light waves have the amplitudes a1 and a2 and intensities I1 and I2 are superposed with each other, interfere with each other, then the what is the resultant amplitude? Resultant light wave amplitude resultant light wave amplitude What is the resultant light wave amplitude? That is capital A. From the figure, we write like this. Right? We have to use just like parallelogram law. Root of A1 square plus A2 square plus 2A1 A2 cos phi. What is phi at here? Phi is the phase difference between the two light waves. Okay? Phi is the phase difference between the two light waves. Phi is the phase difference between two light waves. And now, for example, here we got amplitude of intensity of first wave if you want, right? Okay. Intensity of first wave, what you will get? Intensity of first light wave. For example, this is the first light wave and this is the second light wave. Okay. From S1, the light is emitting, that is the first light, and from S2, the light is emitting, that is the second light. And intensity of first light wave, we write that is I1. We write I1 as A1 square. Intensity of second light wave, I want. Intensity of second light wave, that we write as I2. What do you write I2? I2 we write as A2 square. Is it right? I2 we write as A2 square. And resultant light wave intensity I want. Resultant light wave intensity. Resultant light wave intensity. Resultant light wave intensity is we can consider as I, that is equal to square of resultant amplitude. Okay, this we can consider as equation 1, and from equation 1 you can square on both sides. Okay, then you will get a square is equal to a1 square plus a2 square plus 2a1 a2 cos phi you will get. Okay, this is the important formula. And from this we will write capital A square as I, a1 square is I1, a2 square is I2, 2 into a1 is what it here. You see here, a1 square is I1, a2 square is I2, a square is I. Right? A1 we write as root I1 and root I2 cos phi we write. This is the formula for the resultant intensity. It is the formula for the resultant intensity in the interference. Right? Okay. This is equation 2 we can consider. And now, what is the condition for the bright band? When you will get the bright band, and constructive interference. Condition for bright band. Yes, what is the condition? When you will get the bright band? In order to get the bright band, the phase difference must be equal to the phi should be equal to 2n pi, where n values are 0, 1, 2, 3, and so on. If you substitute this, you will get the result. Here the intensity will become maximum, amplitude become maximum, and intensity also become maximum. Okay, and I am going to erase this, and you take the screenshot and note it, right? The condition for breadband I am going to explain. From equation 1 and 2, okay, what we will get the in amplitude. Amplitude we will get is to the condition for breadband. Okay, condition for breadband we write as phi is equal to n pi. In that first we write phi is equal to 0. Okay, we take n as 0, then phi is equal to 0 you will get. What you will get the resultant amplitude. Resultant amplitude what you will get. The resultant amplitude we will get is from the figure a is equal to we write as under root of a1 square plus a2 square plus 2 a1 a2 cos phi. Phi is 0. Okay, condition for breadband. Phi is equal to 2n pi. We write n as 0, then we will get as 0. This is the condition for the breadband. When you substitute this, then resultant amplitude you will get as from this a1 plus a2, it will be the maximum, right? The maximum amplitude we will get is a1 plus a2. This is equation 3. And maximum intensity also become maximum in the bright band. At the bright band, the resultant intensity will become, we have that I is equal to I1 plus I2 plus 2 root I1. This is from equation 2. Root I1 root I2 cos phi. Phi we write 0 it here. If you substitute it here, then you will get I is equal to, we write root I1 square plus root I2 square plus 2 root I1 root I2 we will get. From this we can also write like this. This is nothing but root I1 plus root I2 whole square we write. This is just like a square plus b square plus 2ab, a plus b whole square we write. Okay, the maximum intensity we will get is I max is equal to root I1 plus root I2 whole square. This is equation 4. The next condition for the dark band we write. Condition for dark band. That is a destructive interference. Okay, condition for the dark band means the phase difference should be equal to n minus, what is the condition? Phase difference, how much it should be? The phase difference should be equal to n minus 1 by 2 into 2n minus 1 into pi, where n values are 1, 2, 3, and so on. This is nothing but the phase difference should be equal to pi, 3 pi, 5 pi, and so on, right? And from that From equation 1, what you will get? Resultant amplitude. Amplitude should be minimum. Intensity should be minimum. Then the resultant amplitude you will get is from equation 1. That is a1 square plus a2 square plus 2a1 a2 cos 180. First value we substitute here. Pi. Then this is under root also there here. This we will get is root of a1 square plus a2 square 2a1 a2 cos pi value is -1. Then the amplitude we will get is a1 minus a2 whole square we write. Square root will cancel. Then you will get amplitude as minimum. That is the minimum amplitude formula is a1 minus a2. We have to subtract. What is the formula for the minimum intensity? This is equation 5 we can consider. Minimum intensity. This condition we will substitute. Condition for dark band we will substitute in the intensity formula also. If you substitute in the intensity formula, you will get like this. From equation 2, we will write the resultant intensity is I is equal to I1 plus I2 2 root I1 into root I2 cos phi. Phi is the phase difference we write as pi for the minimum intensity. We write as root I1 square whole square root I2 whole square plus 2 root cos 180 is -1 here. This is the cos 180, we write it as -1. Then we will get minus 2 root I1 root I2 we will get. This is similar to a square plus b square minus 2ab formula. We will get I is a minus b whole square root a I1 minus root I2 whole square we can write. Here intensity is minimum. That is the minimum intensity formula is the root of I1 minus root of I2 whole square. This is equation 6. Now, if you find the ratio of these intensities, we can try to simplify. By simplifying, we can write at one place what you got here. Okay, and that we got is maximum amplitude we got is, oh, I write the note point. Note what you got here. Maximum intensity what you got, and the minimum intensity what you got, and maximum amplitude what you got, and minimum amplitude what you got. Now you see here, general amplitude formula is A is equal to under root of A1 square plus A2 square plus 2A1 A2 cos phi. And the general intensity formula is I1 plus I2 plus 2 root I1 I2 cos phi. And here breadband amplitude is what? At breadband amplitude is maximum and intensity is maximum. That maximum amplitude is what you got a1 plus a2, and the maximum intensity is root I1 plus root I2. We derived this one whole square. And the minimum in case of dark band, amplitude is minimum and intensity is minimum. And the minimum amplitude is A1 minus A2 and the minimum intensity is root I1 minus root I2 whole square. We write in ratio form, that is I max by I min is equal to A max square by A min square, or A max is A1 plus A2 by A1 minus A2 whole square is equal to I max we can also write as root I1 plus root I2 whole square by root I1 minus root I2 whole square. This is the final formula. This one formula, if you remember, this one formula is important. If you remember this one formula, then you will get everything today's concept. Today's concept you will not get in the exam, but this is important for the problems. Okay, it's just I max by I min is equal. This is the formula. I'm going to draw the box. I'm going to draw the box. Very important formula. This we can also write like this. I max by I min is equal to, in this equation here you see A max we write A1 plus A2 from this. A min we wrote A1 minus A2. A1 plus A2 whole square by A1 minus A2 whole square. I max we write here I max root I1 plus root I2 whole square. I min root I minus root I2. Or otherwise simply we can also write I1 square equal to A1, A1 equal to root I1. A1 by A2 plus 1 by A1 by A2 minus 1. While solving these problems, we will use this concept. Okay, in exam you will not get this one, but based on this you will get the problems. Problems are very important. Let us solve the few problems based on this.